Okay, just kind of doing a little inspection. This is kind of a mess. The edge is a little bit destroyed. You can see that is a broke trace, a broke pad. And the way this is, it's the outsides are ground. The next in are 5 volts. You can see they're connected together. And the two in the center are the 20-volt AC input for the sound, for the audio circuitry. It's 20 right off of the transformer, 20 volts, and that gets rectified with these two guys. And I've checked this one right here. The orange diode is shorted. This is a 4,000 microfarad cap, which I will replace with a 47. The back side is also damaged. This is broke. That's the AC line. So this thing's had some AC problems. Kind of some messiness around a little bit. Not terrible. But there's a lot to go over on this. A lot of repairing to do. Like I said, that one rectifying diode I tested, it is short. So, caps to replace. I don't see any exploded tantalums, which is good. Looks like we have some tantalum axials. Right here's one. I think this is a tantalum axial. Maybe. It's not shorted, so should be good, I guess. Yeah, a lot of green, a lot of these green caps. And I will do some spot checks on some of these green caps to make sure they're not leaky. The brown ones, in my experience, are good caps. Yeah, there's an awful lot of bipolar ROMs on this board that are soldered straight into the board, and I would like to dump all of those. And there's a few here that are not that are socketed, but I would like to dump all of these programmable chips so that I have a software set from this board. It's not in MAME, you know. It's not a microprocessor based game, so it is not in MAME. Yeah. Caps. I'll remove this. Yeah, so it's a bit to do. Cleanup work. I'm gonna, fix this, fix that AC line input, clean this all up, replace both of these rectifiers. I'll go through and just clean up. So I'm gonna do that, and I'm going to start doing some cleanup work on this guy. And I'll be back. Alright, I'm doing a repair here. I fixed that trace with a lead through the through hole. Soldered in. I got the 2 rectifiers replaced. And you see the back side here. I had to replace that trace with a lead going over to here. Okay. And that is now good to go. So I'll put a new cap in here, 4700 microfarad. And yep, that should fix our AC rectification and supply. And yes, a brand new 4700 microfarad capacitor. Nice 105 degree cap. High quality cap. Alright, so our 20 volt AC is fixed with the rectification new capacitor to filter. So that should be good. I've tested this. This guy is good. 5 ohm resistor is fine. I believe it's 5 ohms. Yeah. All right, cool. I think what I would like to do is find a good place to latch on to 5 volts. I'd like to put my power supply on there and see what this thing draws, what kind of current this board draws. Let me do that. Let me find a nice place to hook 5 volts and ground to, and let's check this thing out. What does this draw? Yeah, all right. All right, I have the power supply hooked up, and this is only a 5 amp supply. This is as good as this thing will do. And on the board it's about 4 volts. So this thing is an incredibly power hungry board. It's going to be upwards of 5 amps. Yeah, that's crazy. Just had it hooked up on the rail here. But yeah, measuring on the board was about 4 volts. But it's drawing 5 amps at 4 volts. So that's pretty nuts. No wonder this power supply needs to be so... This thing needs to have both those pass elements to boost the current. This is incredibly power hungry. Incredibly non-efficient right here. But it is what it is. So we will definitely have to use the switching power supply while that thing is not, while the other supply is down. Yeah. So I think that switching power supply can deliver 10 amps, I think. So, all right. Well, I'm going to go ahead and get my harness together. And I'm just going to do DC right now. I'm not going to worry about hooking up AC to this thing quite yet. You know, we'll deal with sound at another point. Let's get this thing up on the monitor, running, and see what it looks like. I think what I might do is get the desoldering gun out and do some spot checks on some of the decoupling and stuff. And make sure we don't have leakage problems on here, because that will draw more current. So let's just make sure that we don't have current leakage or anything like that. So I'm going to do that for a little bit off camera, and I'll be back. And as I had thought that I would find, the brown caps that I'm pulling and spot testing are fine, and the green ones are garbage. I've already replaced 2 of them right there. And I got another one on my leakage tester right now. And you can see the light is still on. It's testing this 50 nanofarad cap that had come out of the board. Yeah, you can see the light's still on. And I'm going to replace that one with this guy right here, which is 47 nanofarad. It's a more common value. You know, I'm replacing a 50 nanofarad with a 47 nanofarad. But and you can see this one is still lit. And you'll see how quickly this light goes out on a cap that does not leak current. There we go. And it is out. We'll do it again. Let me introduce leakage. There it is. And 1, 2, 3, 4, 5. Out. 1, 2, 3, 4, 5. Yeah, that's what it should do. And those green ones just stay lit forever. So yeah, I'm going to have to order more of these though, because I don't have any more. This is my last one, unfortunately. So yeah, these are going to have to all be replaced. These green caps up here in the sound section. I'm going to go through, continue testing, replace what I can, and I'm going to have to order some 47 nanofarad caps because I don't have any more. Alright, I went ahead and replaced the 470 microfarad caps. I've yet to test them for capacitance and ESR. I'm going to do that. I ended up replacing all of the 0.1 caps and all of the 0.22 caps because none of them would charge. You know, they were constantly leaking across the cap. There was actually 3 good capacitors. There's 2.1s and 1.22. The rest of them are over here and they all leak. Yeah. And what that means about they leak is they will not charge. There's constantly current just going across them and preventing them from fully charging and stopping to leak. Current across it. I went ahead and tested all of these tantalums against ground to make sure that none of these tantalums were shorted against ground. And none of them are. So they're all good. And you know, they don't always just blow up. Sometimes they short and you can't really tell. I did not check this guy though. I'll check this one, I'll check this one. I didn't check that one either. Yeah, so this should be squared away now. I do need to order some caps. I need to order some 47 nanofarad caps because I ran out. I got one more right there to replace. I just don't have any more. So, yeah. That is that though. This thing should be good in the sound section now. So happy about that. Oops, that's coming up. Look at that. That's ground. I'm just going to glue that back down. That guy right there. I'll put some glue under that and press it down. Clean it up, press it down. Alright. That is it for now. Now I got to work on my harness so that I can actually hook this up and send it over to the monitor and see what we get. Okay, yeah, those blue capacitors, I tested all of them, and these are original Rubicon caps. Rubicon. And that is a good brand of capacitor, and those all test good. The ESR is right where it should be. Capacitance has drifted a bit high. They're old. They're out of tolerance, but they are not open or short. They're still, they're still doing their job, and they did not leak at all. So, Rubicons are good caps. We've got new ones in there, and we're good to go. So, next is the harness. I did glue that down good. So that trace is repaired. Just glued it. And we're good to go. So, let me go ahead and put a harness together and see if we can see some death race. Okay, moment of truth time. I just have 5 volts, ground, and the video signal. I actually, when I first got the 5 volts hooked up, I set the power supply. And then I did this with the video. So video is 21 or 20, right? Yeah, video and video return. 20 and 21. So that's 20 and 21 right there. Okay. So we have video hooked up. We have 5 volts hooked up, and I've already set the 5 volts. And it's right at 5. So let's go ahead and turn it on, and hopefully we get something on the screen. Nothing's blowing up. No tantalums are blowing up, which is good. There's no video. No video at all. We're right at 5.01 volts, which is great. So our voltage is good. But we got no video whatsoever. Nothing. Nothing at all. Not even a flicker. Nothing. Interesting. Okay. And it's not a brightness issue or nothing like that? I don't think so. Let me see. Brightness. Oh, look at that. What is that? Hey, I see a guy running around. You see him? Gremlin? Whatever you want to call it. How about horizontal sync? Okay. It's kind of working. It looks like there's no horizontal sync or something. Yeah, I don't know. First things first, let's look at the video signal and get video right. That'll be number one. So I'm going to actually have to get the schematic for this and print it off. I do have the schematics. It's in the house on my computer. I just need to go ahead and print it off. And then let's get this thing right first. This is horizontal sync and acting really strange, so. All right. But yeah, it's something. We're getting something. That's kind of cool. So let's get this thing looking right. Okay, I have the timing and video output part of this schematic printed off. Exidy Inc. Garcia Avenue. Got the scope ready to go. Here's our crystal right here. So we'll check the main frequency. We'll check all of this. This looks like our horizontal sync lines. Okay, this looks like probably our these might be our vertical lines. It's hard to tell. Sync prom maybe? Hard to tell. Here's the video out right here. These 04s. So we're going to start right up here with this stuff. Get some frequencies, make sure the frequency's right, and follow the horizontal and the vertical. I don't know if that's exactly the vertical. It may be. Everything on here we'll go over. So let's do that, and we'll be back. Let's do that. What is this? 11A. That's a bipolar ROM. All right. I want to get ahead of myself. Let's just start up here. Okay, so I probed up here on the the crystal, and the clock circuit looks perfect. No problem. I skipped all the way to the video output, and I looked at the signals coming into these 3 inverters, and they looked fine. The outputs looked okay. But we're getting almost nothing on the video. You know, there's no... It doesn't look like a video signal. Let's put it that way. But you know what? I gotta find the sync signal. I have to find the sync signal. Okay. This ITC-SC might be the sync signal because it says sync and it's pointed to there. So maybe this one is the sync signal. I don't know. I should hook this back up and see if we have 15 kilohertz on here. What do we have on this pin? ITC-SC. I'm going to have to look at this part of the schematic a little bit more and find and try to find out where the sync signal is coming from. Horizontal sync. I don't like how they have these labeled. They're not labeled as what they are. They got like cryptic and coded type stuff, and it's hard to tell what's what. So, yeah. Ooh, those signals are all made up here on this guy. ITSCS. Anyway, you know what? I'm going to keep that guy in mind. But what I'm going to do is, because I looked at all of these resistors, all 5 resistors here are, I mean, right on value. So I'm going to look at this capacitor right here. It's a 6.8. It's this guy. I'm going to look at that. I might even replace it. Put a 10 microfarad in there. It'll be fine. Put a new 10 mic in there, and then I'm going to move on to this. I'm going to look at this guy right up here. That's kind of curious. So let's do that. It's a couple things I'm going to go ahead and do. Alright, I'm looking at this 04. That's this guy right here. And I am on pin 11. This is the sync one, right? And that is off frequency. That's supposed to be 15.6, 15.7. So I cannot dial into that. So we're going to have to follow this back and find out why it's off sync. Something's not right. So okay. So we'll go ahead and that is back on this chip. So what I can do is look at the pin 13. Look at and see what pin 13 of 14A is doing. Alright, well, I removed all of the bipolar ROMs from this board, and they all came out nicely, except for 2 of them. 2 of them disintegrated as I took them out, and they were both in the timing section. Now, thank goodness, these ROMs are in MAME. It's non-working, but they are in MAME. So I was able to verify all of them, and 4 of them were bad, and then the 2 disintegrated. So I programmed the 2 that disintegrated And I programmed 4 to replace these. So there were 6 bipolar ROMs. 4 of them definitely bad, 2 more potentially bad that were in that sync circuit. So now I know we've got all good bipolar ROMs. So now we're starting from a good slate there. Yeah. So we got a good software set now. And I did program another one that one of the legs fell off of it. It was really weak. It looked like it had a leg fixed, like a leg soldered onto it, and it just fell off. So I actually programmed 7 bipolars. 4, 5, 6, the 2 that disintegrated, and 1 the leg fell off. So that's 7 total. Yeah. Well, you got to have good software, right? So now we do. So I'm going to go ahead and put sockets in the board where all of these go. And we'll be back. I have gone through and removed all of the old junk sockets that were replaced or that were installed over the years. These ones I think were actually from the factory. I removed those and kind of just cleaned up the traces good. And there were some sockets added onto this board, and this board had a lot of hackery on it, big time. Like right here, hackery. Right over here, mucho hackery. Then hackery on the bottom side of that. The rest of them are just the chips that I removed, the bipolars that I removed. The rest of them are good, but I have some repair work to do up here and over here. And then just resocketing this thing and putting our ROMs back in it, the chips and everything. So I'm going to go through and do some board repair on these couple of spots. And then move on from there. Finish with the socketing, putting new sockets in the board, making it nice. And from the comment, I'm sorry, I don't have it in front of me. I don't know who made the comment, but you know who you are. Somebody commented that the transformer is at risk of burning up due to the bridge shorting rather than opening, which is absolutely true. And the schematic said to fuse this at 5 amps after the power supply. Well, we're going to fuse it before the power supply board. So I put in a fuse, and this breaks the AC line going to that 711A double rectifier thing. Yeah, so it's breaking the fuse right there. So if that bridge ever shorted, it would blow the fuse. Yep. Excellent. Yeah. And I'm going to make sure that that is also breaking the line that goes to the 5-volt the 5-volt regulation circuit as well. One of the legs, one of the 20-volt legs goes both to the 5-volt circuit and to the ground circuit, the reference circuit. So I want to make sure that I'm fusing that lead. That would be the hot lead. So I want to make sure that I'm fusing that lead. So hopefully I got it right on the first try and I don't have to change it. But if it's the other lead that goes off to the 5-volt regulation, then I'm going to change it and fuse that one instead. So all right. Actually, this will work just fine because both of the leads get rectified and go over to the 5-volt the 5-volt circuit. You see both of those leads go in right here and here. Okay, these two blue wires right here, and they are both rectified by these 1 amp rectifiers right here. Both of them are. And then they dump over here, go through this resistor, and then go off. So this will work just fine fusing it, just like this. So we're going to put this back into here. Before I do, I am going to have to drill a hole in here to mount this. So let me do that. All right, and you guys get to see the inaugural use of my new drill press that I just bought. I have a hole marked right here for where I'm putting the fuse. Let's turn our light on. This thing's pretty badass. Anyway, we're going to get this thing lined up decent. Just like that. Turn it on. I got my glasses on, of course. And let's drill it on down. How awesome is that? Boom. New hole. New hole drilled. Now what I'm going to do is I'm going to put a bigger drill bit on, and I'm going to turn it around, and I'm going to chamfer that hole. So let me go ahead and switch this over. This thing's awesome. So we'll just go with a much bigger bit. Like this. Okay. And I specifically got this thing for this. You know, for doing stuff like this where I have to modify something like this. It's just so much easier to use a press. Plus, if I ever have to drill, say, circuit boards, you know, that kind of thing. Let's try this all the way down, see if this will go. Yeah, see, this is tad bit awkward. Do this. Let's just swivel this up out of the way. And I really need to sit something. And let me I'm going to get like a piece of wood or something to sit this on so that it'll sit without wobbling. I'll be right back. Okay, I got a big block of wood here. And it's a little wobbly. It's not ideal, but it'll work for what we're trying to do. I just want to put a chamfer on this. That is all. Like so. So, switch it on. Come down. I think a beveled screw will go in there nicely. Because I want this to be able to sit flat. So I put a chamfer on there. And I'll put like an angled screw in there to mount that thing. That should work good. Excellent. Okay. Yeah. All right. I'll be back. Voila, that thing is awesome. All right. Okay. I have it in here. Unfortunately, I am going to have to get a bigger drill bit so that I can do that. The same thing that's done on there, I need to do here so that I can recess this nut in here. Because I have to have it this way instead of the screw head being down here, because the fuse just doesn't have clearance to sit in here. You know, that has to be flat like that so that the fuse can go in. So I am going to have to get a bigger bit, like a kind of one of them flat head bits to do this kind of work. I don't have anything like that. So for now, this is just going to have to do. But still, it's better than not having a fuse. And it's in there. And yeah, so in how this board was pulling over 5 amps, I think you could use probably put a 7 amp fuse in there. Be good. Yeah, excellent. So I'll do that. I'll grab a 7 amp fuse, pop in there, and then I'm still waiting for these parts. This thing will be good to go. All right, our board. I went through and scrubbed this board with alcohol and a brush, the back of it especially, because there was so much flux and solder work done on this thing. And to properly inspect stuff, you really need that flux off the board so that you can see what's going on. So I went through and I scrubbed the whole entire board, and I'm telling you, when I spray rinsed this with alcohol and let it run, it was running brown off the corner. There was so much flux on this board. So it is clean now, so I'll be able to actually see what I'm working on. And yeah, this is a mess up here, this stuff. I want to be able to clearly see that. Yeah, so okay. Everything that I removed came out great. So we're good to go. I'll go ahead and start putting sockets in and repairing this up here. And then so we got some repair work to do and some socketing and stuff before we're ready to go. So a little bit of work to do, so I'm going to get at it. All right, I am back to looking at this timing diagram. I do not have some of the chips in the board. Those repairs that I have to do, I still have to do. But I should be able to get the timing down and everything. I've got all of the sockets for the bipolars back in, and I got all of the bipolar ROMs back in the board. And we're back to this. And these two 161 counters right here are acting super weird. They're acting faulty, basically. If I move to this guy, 12D, which is right here, and just run it freely, you can see it's just counting all on its own with no clocking. And it's hard to see what is going on with this trigger. I'm going to trigger on the clock, going to a 1. Right? Yeah. It's not picking up the clock for some reason. I have to look into this. Why is it not picking up the clock? Am I not on this right or something? I don't know. Let me mess around with this. No, I've been messing around with this. Now I'm on this one right here. And it also is doing whatever. It's basically counting with the enable, not the clock. Yeah, this is weird. So I am going to have to, I'm going to pull these two 9316s out of the board. These two guys, I'm going to take these two out. All right, I am not finding anything wrong in the timing section so far. I mean, I still have some things to look at. There's a couple 112 JK flip-flops in here that I can look at. Those the 161s I replaced, and it's the same thing. So I don't know. I'm starting to think maybe the frequency, the horizontal frequency on this is 17 kilohertz, and you just got to dial it in. Right now, this is what I got, and you can see the little gremlins running around. So I'm thinking maybe this is just a playfield problem with putting four playfields on the screen. You know, maybe we got counting issues on the playfield side of things, and because it looks like it's horizontally synced now. But it's so weird that it's 17 kilohertz. But I have seen that before, to be honest. I've seen some boards do some weird stuff like this. So I'm thinking that maybe this is just a different issue, and it's not related to the sync problem. So, yeah, I don't know. Yeah, okay. Anyway, I'm going to move on to other sections. I'm going to look at the schematic and see if there's a like play field or something like that. See what else is going on here. Alright, well, I've been doing quite a bit off of camera, and I gotta say, this is extremely frustrating. I've went through and basically replaced everything that is involved in this horizontal sync rate circuitry. I've replaced the counters. I replaced the 04 that oscillate the crystal. I even replaced the capacitor in the crystal circuit. I replaced 9B, which is a 7437, which handles all this crystal stuff, or clock stuff. I replaced both of the 112s, the JK flip-flops, even though I tested them and they were fine. I know that sometimes chips internally, they'll test okay, but internally there's something wrong with them, that they skew the signal and they disrupt the signal somehow, and it just doesn't work. So on the off chance, I just replaced stuff. I replaced these two guys. I replaced these two guys. I replaced this 174 up here. I replaced this 112. Yeah. Bottom line, the only way that I can get this on the screen like this is by changing the crystal. I've dropped the crystal down from the standard 14.391 megahertz to 12.096. I just kind of tacked that crystal in there. And that gives me a horizontal frequency of 14.5 kilohertz, which apparently is close enough to where I can tweak this thing. And it's off the screen a little bit, you can see. But at least I get something on the screen here. Now, obviously, this has to work the way it was engineered with the original crystal and everything, but I'm not seeing how that will ever sync to this monitor, because no matter how you look at it, the horizontal frequency with the standard crystal is 17 point whatever kilohertz, and it will not sync to this monitor. So I really don't know what to think about this. And it's kind of goofy. There's some randomness going on because I've got chips missing up here and stuff. So there's that. But I'm going to leave it like this for now so that I can actually see what I'm looking at and what I'm working with. But I'm going to end this part of this video right now and take comments from some of you guys. What is going on here? Can someone explain this to me? Why? Does anyone have any experience with Death Race, the game, and these boards, this board, about that frequency? I am open to suggestions. Yeah, I don't get it. I don't see how this thing will ever sync to a standard resolution monitor being 17.5 or whatever it is kilohertz rate. So I'm going to stop this one right here. Please comment below and let me know your thoughts, any suggestions. I'm open to it. All right, guys. All right. Now, quick addendum. Now, we'll end it after this video, because I did the repairs up here and populated these chips. And I beeped it all out, and it's all good. And these are like the car circuitry and stuff like that, which it's wavy. It settles down with that crystal in it, but it's just not right. But you have your cars. The cars are good. And they just kind of randomly show up. When you turn the game on, they're just random. And these dudes are running around, the gremlins or whatever. So, okay, I'm to the point now where I'll take suggestions. What do you guys think about this with that frequency weirdness? All the damage is repaired, beeped out, done well. It's good to go. That looks pretty sloppy right there. I should check into that. Anyway, yeah, we'll go ahead and end it right here, and I'm really anxious to hear your guys' thoughts on this. We haven't even got to sound yet or anything like that. I'm kind of stuck on this video issue. This goofy frequency. You know, I'm kind of want to just go through the sounds, make sure the sounds are all there, and send this back to the owner and have him put it into his cabinet, you know, and see what happens. To be honest, that's kind of my thought process. But go ahead, leave some comments. What do you think? Suggestions, and that's it for now. That's it for now. We will get back to this guy for sure. But for now, just know before you comment and everything, I've basically replaced everything in that timing circuit. I've tested everything 100%, and everything was good. And I just went ahead and went through and replaced the 112 flip-flops that were in the circuit. I've replaced all of the 161 counters. The proms are good. Remember, I programmed new ROMs. All the gating chips and everything, all tested good. It's just It's a frequency thing. I don't know. It's just weird. All right.